All right, greetings, Algebra 1 students. For those of you guys who don't know, this is Mr. Tucker, and I'm sure you're all wondering, now that the SOL is over, what are we going to do for the rest of the year? The question is, free time? Not so much. Instead, we're actually going to be learning some topics about geometry. Now, we're going to try to make this as painless as possible. So, most of you guys are going to be taking geometry next year, or maybe you're taking it over the summer. And we want to give you a sneak peek into what we're going to be doing next year. So here's the rules. Everybody's going to get a worksheet. And you need to write on your own worksheet. So everyone is going to turn in their own work. And you're going to have to turn it in at the end of the period. The nice part about it is you get to work in groups of 2 or 3. And like I said before, at the end, you're going to turn in assignment at the end of the class. All right, so that's going to be our game plan for today. Now, if you haven't already, go ahead and make a real quick group of 2 or 3. You can work together, you can collaborate. However, everyone has to turn in their own work. All right, here we go. So, what are we learning about today? Angle pairs, all right? And if you look at your worksheet, you see it jumps right in with some definitions, okay? So when you see this word, complementary angles, it's real simple. Those are 2 angles that add to 90 degrees. Now, hopefully you guys know what a 90-degree angle looks like. It's also called a right angle, which you'll notice we denote with this little box down here. So when you see 90 degrees, remember that also is like a right angle. Okay? So we all know what a right angle looks like. All right? Now, so the key is, you just need to ask yourself, do these angles add up to 90 degrees? Well, here, if they have separate angles, you can just add 30 plus 60. And if it equals 90, we're happy, and they're complementary. All right? Now, sometimes they're separate, but they can also be adjacent, or in other words, joined at the hip. Sometimes you see that they share a side, right? So here's angle 1, here's angle 2, but they have a side in common. Let me just highlight that, my fancy smancy highlighter. They have a side in common, so that makes them adjacent, right? But still, you can either add up the 30 plus the 60 to get 90, or you just realize, hey, you can see right together when you put them side by side, they make that right angle. So of course they're going to add up to 90, and of course that makes them complementary. All right. Same idea down here. Supplementary angles. Instead of adding up to 90, now they're adding up to 180. And I don't know how much you guys know about degrees, but 180 degrees ends up making a straight line. Here's 90 degrees. If I opened up and stopped here, that'd be 90 degrees. Well, instead, I'm opening up another 90 degrees, which is taking me to a straight line. All right, so that would be a 180-degree angle. Looks kind of silly, but it's really just a straight line. So again, they can be separate. And in that case, you would just test, does 120 plus 60 equal 180? Sure does. So they're supplementary. Or they can be adjacent. Here again, they're sharing a side. That way, you don't even have to add these together. You can just look at it and see, uh-oh, they share a side, and the result is a straight line. So, of course, they have to be supplementary, because I know a straight line is 180 degrees. When that happens, when they're adjacent and they're supplementary, we got a new vocabulary word, and that's when we say that they are a linear pair. Now, think about this for just a second. Why do you think they call it a linear pair? And if a teacher is ready to go, Can you pause this? Let everybody think about why you might call this a linear pair. Go ahead and pause it. All right, hopefully somebody came up with the idea that we know linear means a straight line, and if I look at a linear pair, I see that the result of putting the two angles together is a straight line. That's why they call it a linear pair. All right, linear pairs can also look like this, and as you can see, the key thing here is that they form a straight line. Again, two angles together form a straight line. Whoa, that was crooked, but got a little help there. So here are the two angles. Here's an angle, there's an angle. Together they form a straight line, hence they're linear pairs. All right, let's keep on chugging. So, come on. Let's go a little further down. All right, so let's look at what you guys have to do. Your mission: decide if the angles are complementary or supplementary, then decide if the angles are adjacent or not adjacent. Let's see here. All right, well, let's look at the first one. First off, let's remind ourselves, to be complementary means two angles add up to 90 degrees. Supplementary, they add up to 180 degrees. So let's look at the first two. Uh-oh, I don't have any angles to match up. So can I tell if they're complementary or supplementary? Well, think about what it means to be complementary. It means 90 degrees or what type of angle. So you need to decide, is it complementary or supplementary? Adjacent or not adjacent? To be adjacent means, do they share a side? So we could say adjacent or non-adjacent. You guys need to decide. Complementary or supplementary for each one, then decide, are they adjacent or not adjacent? Go ahead and pause the video now and see if you can come up with the right answers. All right, if you did it right, those should be your answers. So check to see how it went. Complementary and adjacent for the first one, supplementary, non-adjacent, supplementary adjacent, complementary non-adjacent, complementary adjacent, supplementary non-adjacent, supplementary adjacent, and supplementary, whoops, that should be non-adjacent. Sorry about that. All right. Not so bad, right? On to the next page. Okay. So next it asks us for each, find the value of the variable. Well, let's use what we know. These two angles are clearly complementary, right? Because they add up together to give you a right angle. So that means whatever this angle is, and I don't know what x is, but I know that when I add the degrees from x to 33, together I get 90. So I can set up a real basic equation. Angle x plus 33 degrees equals 90 degrees. That's a simple equation that I can solve by subtracting 33 from both sides. So I know mystery angle x equals 57 degrees. Over here, okay, I got two angles. I don't know what either one of them is. But I know that together I can clearly see that they're a linear pair. They're a linear pair because the two angles share a side and they're supplementary. So they're adjacent and supplementary. That makes a linear pair, straight line. Now I know when I add those two angles together, I'm supposed to get 180 degrees. Well, I don't know what x is, but I know x plus 2x has to equal 180. Well, now I can combine my like terms. X plus 2x equals 3x. So when I got 3x equals 180, divide by 3 to get x by itself, and voila, I know that x equals 60. All right? So we just found x using our knowledge of solving equations and supplementary angles or complementary angles. We could solve for x. All right? So now it's your guys' turn. Try it out. Go ahead and pause the video and see what you can do. All right, if you did it right, these should be your answers. C is 113 degrees, X is 26, Z is 90, Y is 136. And of course, you got to show your work to get full credit. There's 5, 6, 7, and 8. 18 degrees, 78 degrees, 116, and 88.5. ¡Qué fácil! ¡No! ¡Qué fácil! All right. So after you check your answers, we got one more sheet to go. This is so easy. Here we go. Last vocabulary term, vertical angles. Two angles whose sides are opposite rays or look like an X. All right. And it gives you an example here. So angles 1 and 3 are vertical angles. You see how they're on opposite sides of this X? Whereas angles 2 and 4 are also considered to be vertical angles. It's kind of like they make a V shape. How about V for vertical, right? Here's a nice little, if I were to highlight it, let me do this. Here's a nice little V shape. Another V shape. There it is. They are, oh, that one it didn't like. That's why they call them vertical angles. And the key thing is, vertical angles always have the same measure. So angles 2 and 4 are equal to each other. And measures of angles 1 and 3 are also equal to each other. All right. Key thing here is it looks like an X. So anytime you have two angles that are two lines that intersect, you know that the angles that are across from each other are always going to be equal. All right. And that goes for both pairs. Okay. So there you go. That's a little symbol that shows that they are equal. All right. So in the notes, it's the same idea. We're still trying to solve for the variable. Well, now it's an easier equation. Step 1, we got to write an equation. Well, if I know this angle is 28 and I know the one opposite of it has to be equal to it, my equation is that X equals 28. Well, that's easy to solve because I know he is the same as him. Over here, okay, I know these two angles are equal to each other. So X plus 45 has to equal 2X minus 19. Now we got to solve it. All right, I got to combine like terms. Here I go. Subtract X from both sides. And you see that the X's on the left cancel out. But now I rewrite it. 45 comes down. 2X minus X leaves you with just X. The negative 19 came down. Now I need X by itself. So if we add 19 to both sides, these guys cancel out. And 64 equals X. ¡Qué fácil! ¡Qué fácil! ¡Qué fácil! All right, your turn. Okay, this one should look very familiar from the notes. Same with number 2, number 3. All right, 4 is a little tricky, and then 5, 6, 7, and 8 get fun. All right, look back at the notes, see what you can do. Pause the video, and I'll meet you on the other side. All right, if you did it right, you can check your answers. First row, X equals 28, 165, 48, 90, no big deal. Bottom row got a little more complicated. You got 63, 29, 64, and 28. Now, if that went a little fast and you want to go back and watch part of the video again, here's what you can do. Go to the School Fusion page. And let's see here. Freedom. Oh, there we go. So you go to freedom.groupfusion.net. You can even do one other thing that'll make it a little faster. If you type in Tucker first, tucker.freedom, you go straight to my page. That's great. Pick on, I'm going to put a link. Maybe I'll make a discussion topic. Well, it'll be a link right here that tells you where to go. Or you can just search on YouTube for Mr. Travis Tucker. And some of the videos might pop up. Where do I want to go? There it is. There's one. and that'll take you to the channel as well. All right, and then you can just pick the video that you need. All right, happy watching. Enjoy.